Video notes for Exponential Models 2. Go ahead and turn in your video notes, or aka claw in this case, to this problem. Let's do the birthday money problem together, shall we? We shall. So we have Stephanie turned 10 years old. Her grandparents gave her $100 for her birthday. Lucky girl. Stephanie put the money in a savings account and did not make any more deposits. Deposits means she didn't add any more money to it. She didn't withdraw any money from her account either. That means to take out any money. On her 18th birthday, Stephanie had $165.50. So she waited 8 years to get $65.50. Well, I guarantee you, we probably wouldn't have that much money at the interest rates nowadays. Identify and define your independent and dependent variables. So the two numbers. First number here is her age. So we're comparing her age, which represents years. So the beginning age of 10 is going to represent the year 0. The year 0. Because that's how many years has passed when she put her money in savings. And at 0, she put in $100 into her account. So our independent is going to be her age, or time. Her dependent variable is going to be money. Money is going to depend on time. And money, believe it or not, has different units. And of course, we're going to use dollars. So there you go. So for time, we are going to use X. For money, we're going to use Y. You can use whatever letter you want. Now, it says write an exponential equation that models this situation. Show your work. Ha ha ha. Show your work. Okay? Well, I'm going to show you how to get this equation using your calculator, and I will show you how to get this equation using algebra. Okay? So, first of all, we need our 2 points. So when time is 0, because no time has passed, she put $100 in. And then on her 18th birthday, that would be how many years? 18 minus 10. 8 years later, she ends up with $165.50. Okay, using our calculator to come up with this number, we're going to turn our calculator on. Second plus 712, clear the memory. Stat, edit. Okay, plugging in our numbers. So 0, 8, 100, 165, 50. Oops. Okay, so we only need 2 points. Then we're going to go to stat, arrow over to calculate, and I'm going to go ahead and arrow up to 0. Exponential regression. Enter. Okay, I'm going to go ahead and go down here to store regression. I'm going to store it in y equals. So to store it in y equals, we're going to press vars, arrow over to y vars, click 1 or enter, and I want to store it in y1. Enter, enter. So there's our equation. I'm going to go ahead and round this here. 1.065 looks like a good number. We're going to get a better calculation if we use all the decimals. That's why I stored it in y equals, so watch what happens when I go to y equals. It's all there. I don't know why they put all these zeros here, but I guess the calculator does that. Anyway, puts all the decimals in here, gives you a more accurate answer. Okay? Alright, how to do this using algebra, I'll come back to it if there's time, or I might, you saw the Patrick JMT video, everybody except for first period. Same way he did it. Same way he did it. C, is the situation growth or decay? Well, our B value is greater than 1. Our B value is greater than 1, so we have a growth. Is the percent an increase or a decrease? Well, obviously it's growing, so it's a decrease. It says, what is the percent? Well, we're going to look at just this part right here. Okay, 0.065 without the 1. Move the decimal over 2 places. 6.5% increase. That's how you do that. Make a table. Well, we got it in here. Second graph. There you go. 5 points. I would choose the first 5 points given. Write them down. E, sketch a graph. Label axis and scale. So I'm going to put money over here, time over here. So we're going to start off here at $100, and then over time it's going to increase. I'm going to go ahead and put right here 8 years, $165. 50 cents, 0, 100. Close enough. State a reasonable domain and range. Well, domain is our time, so we're going to start off at 0, but not include 0 because we haven't accrued any interest yet. And we're going to go for 8 years. And the range, at 0 we had $100, and at 8 years, $165.50. Remember the word reasonable. Okay, we do not want to go to infinity. We want to use numbers that make sense to this problem. If Stephanie does not touch her money, how much will she have on her 20th birthday? Simple way of doing this. You can use your calculator, but mathematicians out there, use the equation. $352.37. 20th birthday, how many years is that? 20 years. So we would plug 20 in for X. So Y, which is money, equals 100 times 1.065 to the 20th power. Now it's going to come out a little bit different because we rounded our decimal, whereas in the calculator we used all the decimal places. It's going to be different. So let's see what we get. So 100 times 1.065 raised to the 20th power. Now, how big of a difference is it? How big of a difference is it? Not big at all. $352.37 using all the decimals. $352.36 rounding it. Predict the time it will take to double. Okay, so we want to double 100 to 200. Solving for time, which is X. Divide both sides by 100. Take the log of both sides. Bring that x down. Divide by the log. Alright, let's see what we get. Log of 2 divided by log 1.065. So 11 years. Alright, let's see what our table shows. Double our money. Go into our table. We're going to 200. Oops, got to go up over here. Alright, so 100 to 200. 200 is pretty close. Pretty close. 199.92. Pretty close to 200. 11 years. 11 years. Alright, we're at 11 minutes. Remember, to come up with this equation, you have to use 2 points on your exponential graph. 2 points. Plug in for y and x. Solve for a. Plug into the other equation. Solve for b. I don't want to make this any longer than it is, so I'm going to go ahead and end the video now. Have a good evening. See you guys tomorrow.